Hi guys, welcome to today's video. We're going to be working on the study guide problems. So in class, we kind of set up everything you need to do for the first three. So if you have questions about this tomorrow, I'll go over it, but all you have to do is fill in the blanks here and solve the equation for x. And then same thing here, and then you just find the angle measurement. So we can do number 4. So, well, no, we can do number 4. So for number 4, you have to fill in the blanks. So you put all 3 of the interior angles in the blanks. So you got a 25 and a 30 and an X. So then you circle and box, and you just do VC. Got 1x, and then negative 25, negative 30, and 180. Add those together. And that's 125. So since x is 125, that means that since there's just a question mark here, this one is 125 degrees. So you would write it like this with a little degree symbol. Okay? For this one, the answer that you're going to get for x is negative 4. So x is negative 4, but the question is asking the angle measurement for angle A, which is this angle here. And this angle has x plus 24 inside of it. So you take your x value, negative 4, and you add 24 to it. So negative 4 plus 24 is 20 degrees. Okay. These 3 we also did in class, so you should have copied this down on your study guide to do that with. So this one's a linear pair, alternate exterior, and vertical. Okay. Same thing with 10 through 12. We pretty much got through all of these. You guys did these. You know how to do these. You just fill in the blanks, and you either do blank equals blank for the congruent ones, like alternate exterior and corresponding, and you do blank plus blank equals 180 for SSI, SSE, and LP. Okay, so you just set them up like that and solve. And you guys are pretty good at that, so I wanted to spend most of the time in this video reviewing the transformations. So for number 13, we said the answer was D. Which of the following transformations would not preserve size and shape? The only one that would change the size is a dilation. So a dilation of any scale factor would not preserve the size and shape because it would change the size of that, and that means that those are not congruent. All the other 3 transformations are congruent to each other. Okay? For number 14, we did not get to in 4th period, so I am going to go over it here. If you already did this one and you understand it and you don't need to hear it again, you can go ahead and fast forward a little bit. Okay. So for number 14, it says the rectangle below is rotated 180 degrees counterclockwise around the origin. Which of the following is a vertex? That word vertex just means like one of the corners of the shape. So just which of the following is going to be one of the corners of the rectangle's image, so the new one. So these are the 4 corners right here. And the corners have coordinates. So this one is 4 and 1, this one's 1, 1, this one's 1, 5, and this one's 4, 5. So after we rotate it 180 degrees, it's going to have different coordinates. So they're just asking, what are the coordinates of the new rectangle? Or which one of those is a coordinate of a new rectangle? So I'm going to take some patty paper, and I'm going to trace the rectangle. Okay. Now I'm going to rotate it 180 degrees counterclockwise. So that's going this way, and that'll be 2 turns. So here's 1 turn, and here's 2 turns. So that is a 180-degree rotation of the rectangle. So looking at the answer choices, so A says -5 and +1, which is over here. That's not on the rectangle, so it's not A. B says -4 and -1, so -4 and -1, that's the right answer, because that's right on the rectangle. So the answer choice is B here. Easy enough. Okay, moving on. Number 15, which transformation could have been used to map figure A onto figure B? So I asked you guys in class to just look at these and see, what you thought. Obviously, a dilation has happened here, right? Because it went from being a small parallelogram to a large parallelogram, and the only transformation that changes the size of something is a dilation. So you can automatically cross out translation, reflection, rotation, or reflection. It's either going to be A or D. I know I already circled the answer. But it's a dilation and a translation, because a reflection is like a mirror flip, and this one did not flip. It just slid up a little bit into the right. So it had a dilation because it got bigger, and a translation because it went to the right. So it's A. Okay, 16. Triangle ABC has 3 coordinates, so those are ordered pairs, right? With a negative x value and a positive y value. What transformation would place its image, so the new one, in quadrant 3? So let's remember our quadrants here. Quadrant 1, where everything is positive. Quadrant 2, where x is negative and y is positive. Quadrant 3, where they're both negative. And quadrant 4, where x is positive and y is negative. So right now, we have a negative x value and a positive y value. So that means that our triangle ABC is somewhere in quadrant 2 right now, because it says it has a negative x value and a positive y value. So they're asking us what transformation would place the image in quadrant 3. Okay. So a rotation 180 degrees counterclockwise. So a 180-degree counterclockwise rotation would take whatever's here, and it would take it 2 quadrants, or sorry, it's counterclockwise. Yeah, it would take it 2 quadrants this way. So would that be quadrant 3? No, that would be in quadrant 4. A 180-degree rotation would end up here. So it's not A. B says a translation 8 units to the left and 5 units up. So if you're in this quadrant and you go 8 units left and 5 units up, you're still not going to be in quadrant 3. You would still be in quadrant 2. Okay? C, a reflection over the x-axis. Yeah, looks like that's the right answer, because here's the x-axis. And if our triangle is here in quadrant 2, if it reflects over the x-axis, it's going to end up in quadrant 3. Okay, so that is the correct answer. All right, number 17. The figure shown below was transformed from quadrant 2 to quadrant 4. Which transformation best represents which? This transformation represents which of the following? So we have to see what happened here. So a reflection over the y-axis followed by a translation down 6 units. So a reflection over the y-axis would take us here. And then a translation down 6 units would be like down here. But it would have, this one has been like flipped over again. So it has not been flipped over again. So it has not been translated down. This looks like it would be a reflection, another reflection. So it's not A. Okay? A reflection over the x-axis followed by a translation 5 units to the right. So I think it's that one, because a reflection over the x-axis would make it like this right here, and then translating it to the right would put it right here. So I think it's B. Let's look at C though. C is an x-axis reflection followed by a dilation. No, definitely not a dilation because those are the same size. Okay, D says a rotation 90 degrees clockwise, so let's see what that would look like. Followed by a reflection over the y-axis. So here's our pre-image. Okay, a 90 degrees clockwise rotation would take us here, and then if we reflected that over the y-axis, it would flip it down this way. So the orientation, it wouldn't be on the bottom anymore. Like it would be standing up on its side. So it's not a y-axis reflection. Okay, so B was the correct answer. Okay. Okay, number 18. The coordinates of Z after it's reflected over the x-axis. So Z, it's hard to see right here, but it's -2, +2. After an x-axis reflection, remember when something is reflected over the x-axis, the y changes to the opposite sign. So up here, the y value is +2. So the +2 would change to a -2, and you would get -2, -2, which is D. You could show this on the graph too if you want to reflect it over the x-axis. So remember, everything has to be the same distance from the line of reflection. So Z prime would be there, X prime would be here, and Y would be here. I think I made it a little too wide. Yeah, so your x-axis reflection would look like that. But point Z would be at 2, -2. Okay? Give the coordinates of x after a 270 counterclockwise rotation. So x right now is +3, +3. And we can use our paper. Okay, here's x. And we're going to go 270 degrees counterclockwise. So we're going to go 3 turns, okay? 1, 2, and 3. So then it would be at +3, -3. B. And remember, without a graph, the rule for 270 degrees counterclockwise is the same as 90 clockwise. So the coordinates switch places, and then you change the sign of the one on the left. Or sorry, on the right. Clockwise is this way. Yeah, so 3 and 3 switch places, and then you change the sign of the one on the right, and that's 3, -3. Okay. Rodney reflects triangle ABC over the y-axis. The coordinate pair for point C is 2, 5. What are the coordinates for C prime after the reflection? So a y-axis reflection, the x changes. So we have 2 and 5, and the x is a +2. So the +2 is going to change to -2. So it becomes -2, 5. And that's B. Okay, 21 is a good one, an easy one. Which transformation will not result in a congruent figure? The only one that will not be congruent is a dilation. Okay. Which is false. 22. about the resulting image of a rotation of 90 degrees counterclockwise. So, which is false. We want to look for something false. So, the size of the figure is the same. Rotations do not change the size, so that one's true. So it's not A. The corresponding angles are congruent. No, rotations are congruent, so everything about them is congruent, including the angles. The two figures are congruent. That's also true. D says the orientation. Orientation just means like the direction that it's pointing in. So like if you take a triangle like that and you rotate it, it's not pointing in the same direction anymore. Okay, it's pointing in a different direction. That means the orientation is not the same. Okay, here's a little chart. Triangle ABC undergoes a translation, resulting in triangle A prime, B prime, C prime. The chart below shows the coordinates for the vertices of each triangle. Which of the following describes the translation depicted in the table? So we're going to see what happened. Let's look at the x's first. So let's look at A. It went from 7 to 10. So it went up by 3. So up 3, right? They added 3. And now let's look at the y. The y went down 2. Oops, sorry guys, I didn't mean to put up. I meant to put from, since the x went up, that means it actually went right. Okay. Yeah, it went right. Because when we increase on the x-axis, that means we go to the right. So this one went from 7 to 10, so we went right 3. And then it went from 5 to 3, so that's the y. The y went down by 2, so the shape goes down 2. So it went 3 units to the right and 2 units down. And all the points are going to have the same thing done to them, so you don't even need to do it to B and C, but we can. So like -2, when you move it right 3, it gets to +1. So -2 plus 3 is 1. The same thing with 6.5. 6.5 plus 3 is 9.5. So it went right 3 because they added 3. And for the y's, it went from 1 to -1, and we know that 1, when you go, like if you're at 1 and you go down 2, then you're at -1, because 1 minus 2 is -1. Same with -2. -2 minus 2 is -4. So it works for all of them. You only have to do it with one though. Okay? And that is B. Okay, describe the transformation done on FKW to form RNG. It looks like a rotation. So FKW triangle is the pre-image because this one is listed first. It's saying what was done to this triangle to form this triangle. So this one is our pre-image. I'm going to use some patty paper because it's definitely a rotation. Okay. Here we go. So let's see. It looks like it went this way. Yes, it did. So that way is 90 degrees clockwise, because this is the way the clock turns, right? If you're here, the clock keeps turning clockwise and you end up here. That's a 90 degrees clockwise rotation. Okay? So that's B. For A, a 90 degrees counterclockwise rotation, that would have been going the opposite way. So a 90 degrees counterclockwise rotation will take you here. Like right there. Okay, a reflection over the x-axis would flip it, like it would be like a mirror image over here. So the triangle would have to be pointing down. And then translation right and up, that would take it right and then up. So that wouldn't rotate it at all. So it's definitely B. All right, guys. Make sure you look over your notes. Do some more problems in the packet if you need to study more. And I will see you tomorrow.